Hello everyone, welcome back to our channel. Today we are going to discuss about single number problem. Here the question is given a non-empty array of integers, nums, every element appears twice except for one. Find that single one. So here the question is every element appears in the array twice, only one element appeared only one time. So we need to find out that single number. You must implement the solution with a linear runtime complexity and use only constant extra space. So let's understand the question with the following examples. So in the example 1, our nums array is 2, 2, 1. So here 2 appeared 2 times and 1 appeared only one time. That's why output is 1. And in the example 2, nums array is having 4, 1, 2, 1, 2. So here only 4 appeared only one time. That's why 4 is the single number. And in the example 3, nums array is having only single number, that is 1. That's why the output is 1. Let's understand the approaches to solve this problem. So approach number 1 is the brute force approach. So in the brute force approach, in general, we go through the two loops. Let's say here we'll start our int I equals to 0, I less than nums dot size. So in general, in brute force, our logic is if nums of I equals to j, then we'll increase the count. So with this, we can say the number appeared one time or more than one time. So this is the basic brute force approach. But with the brute force approach, there is one problem. As we are traversing the array two times, so the time complexity is O of n square, and we are not using any extra arrays. That's why space complexity is O of 1. So to keeping in mind, in the question, they mention like you must implement a solution with the linear runtime complexity. Means linear runtime means O of n, but here with the brute force, we got the O of n square. That's why this approach is not efficient approach. So let's discuss about other approach. So our second approach is using sorting. So with sort, our nums array looks like this: 1, 1, 2, 2, 4. After sorting, array looks like this. Now we can check the adjacent elements, and the element which does not have a duplicate, that is the answer. So this is compared to brute force approach, some extent this is the better approach. But here the problem is if we talk about time complexity is of n log n, because we are traversing, and on the top of this we are doing the sorting. That's why O of n log n. And the space complexity is we are not taking any extra space. That's why it is O of n 1. But in the question, we need to solve this question with the linear time complexity, which is O of n. That's why this approach is also not as suitable for this one. Let's try to understand another approach. So our next approach is using hash map. So in the hash map, we are going to count the frequency of elements. After counting, the map looks like this. So 4 occurred only one time, and 1 appeared two times. That's why frequency is 2, and 2's frequency is 2. So now by checking the map, which element has frequency is 1, then we can return that element is the single number. So this is simple yet efficient solution with larger arrays also. But let's talk about time complexity. Here we are traversing the loop only one time. That's why time complexity is O of n, which satisfies our question also. But space complexity, to store the frequency of elements, we need to take one unordered map. That's why space complexity is O of n. But in the question, they mentioned that use only constant extra space. So that's why this approach is not suitable for this one. Let's talk about another approach. Let's talk about our final approach, which is bit manipulation. So here we are going to use XR. So the key property of XR is, if we apply XR on same numbers, let's say if we do XR for same numbers, then the result is 0. But if we apply XR with on 0, the result is X. So this is the key technique. Let's apply this technique on our nums array. So first we are doing the XR for 4 and 1. So which is result 5. Let's write this in binary form and do XR. So for 4 binary form is 0 1 0 0 and 1 is 1. So if we do XR 1 0 XR 1 0 1 XR 0 1, so which is 5. Now let's apply XR on the result. So I'm applying XR on 5 with the next number, which is 2. So if we apply XR on 2, 0 0 1 0. So 1 0 1 0 1 1 1 0 1. So the result is 7. Now apply XR on 7 with next element 1, which is 0 0 0 1. So XR on same numbers, the result is 0. That's why 1 XR 1 0 and 1 0 1 0 1 0 1 0, which is 6. Now XR on 6 with our last 2. So 2's binary is 0 0 1 0. So 0 1 XR 1 0 1 XR 0 1. So the result is 4. So in this array the single number is 4. So with this technique we can solve efficiently this problem. Let's talk about our time complexity. So the time complexity is we are traversing the array one time, that's why it is O of n. And space complexity, we are not taking any extra arrays or maps, that's why space complexity is O of 1. So this is the best approach to solve this problem. Let's try to code for this one. Here I am taking one result variable and let's traverse the array. Result equal to result XR num. And in the end, we need to return result. Let's try to run the code. So our solution got accepted. Let's try to submit this one. So all test cases got passed. I hope you understood the problem clearly. If you have any doubt, please do let me know in the comment section. And please do like and subscribe to our channel. Thanks for watching.